Hey everybody, welcome back to my podcast, Anatomy and Physiology Bit by Bit. This is your host, Dr. Steve Sullivan, coming to you from the suburbs of Philadelphia, where I have been teaching anatomy and physiology since 2002 at Bucks County Community College. I'm glad that you're back with us for the second half of the autonomic nervous system. So this is part 2. In this episode, we're going to talk about the neurotransmitters and receptors that are used in the autonomic nervous system, as well as the central control from the central nervous system, the autonomic tone, which is the baseline activation from the autonomic nervous system, as well as what we call dual innervation, which is what happens when an organ or a tissue is innervated by both motor divisions versus when it's only innervated by one. So those are pretty important topics for any A&P course, and clinically extremely significant because a lot of conditions are associated with the neurotransmitters and autonomic tone and things like that. So this is a good one to be tuning into. Also, we have a guest today. Our guest is not only my good friend, Dr. Beth Kersten, but also she is a contributing author on my project, Anatomy and Physiology Digital Suite from McGraw-Hill Education. Beth has been working on it for some time now, probably 2 years, I think, and she does amazing work to help provide supportive learning resources that go along with the tutor videos that I've been creating for several years. So I'm really excited to have Dr. Kersten with us today. It's a really good conversation. We're going to talk about some of the real innovative things that she does in her classroom, which is at the State College of Florida. I've actually been to her campus recently. I went down there for a visit, and it is a really, really nice campus. It is on the Gulf Coast of Florida, and Beth's been teaching down there for quite some time, and I got to see her at a recent conference do a demonstration of some of the really cool, innovative things that she does in her classroom to help her students master anatomy and physiology. So she's another anatomy and physiology professor, and she's another McGraw-Hill author. She also is an author on another textbook called Anatomy and Physiology from Gunstream, and that is also a McGraw-Hill textbook. In addition to her helping out with Anatomy and Physiology Digital Suite, putting together some of the awesome bulleted narrative content that goes along with the tutor videos. So I'm really excited, once again, to have Dr. Beth Kersten with us today, and I hope you enjoy this conversation as much as I did. Dr. Beth Kersten, my good friend from Florida, thank you for joining me and welcome to the podcast.
Oh, thank you for having me today.
So, Beth, you are down at the State College of Florida, right?
Yes.
There's multiple campuses, right? Which campuses are you on?
I'm primarily in the Venice campus, which is in Venice, Florida. We're about 30 minutes south of Sarasota on the West Coast. But we also have a larger Bradenton campus, which is north of here, and a small satellite campus in Lakewood Ranch.
Okay, and which campus was I on when I came to visit?
You were at Lakewood Ranch.
I was at Lakewood. That's right. Okay, so that's a lot. This is a pretty big school, huh?
Yes, and we're actually building a new campus in Parrish, which is a little bit closer to Tampa. We
Okay,
just got funding from the state to start breaking ground quite soon.
but you're not originally from Florida, right?
No, I'm actually from your stomping grounds right now. I grew up in Pottstown, Pennsylvania, and I went to Temple University for
Oh, yeah.
undergraduate and grad school.
So you're a bit of a Philly person.
Oh, yes, definitely.
Yep, I knew that. So at Temple, what was so you're an anatomy and physiology professor. What was the focus of your education? What got you into A&P?
I sort of backed into it. I was pre-med for most of my undergrad. And then halfway through my senior year, kind of realized I never wanted to treat patients. My true love was actually anatomy and research. So
Okay.
when I changed to pursuing graduate school, I got in with my comparative anatomy professor. So I was his TA for comparative, and then I was his lab coordinator. So he kind of fostered my love of all things anatomical.
Okay.
And I was able to, my last year in grad school, take human gross anatomy at Temple Medical.
Oh, fun.
Yeah. So I've
Yeah.
always loved anatomy and physiology. It's always been something I've enjoyed.
Yeah, same here. I think that's very similar to me. I like the getting in the gross lab with the cadavers was just such a great prep for doing what we do.
Hmm.
Yeah.
Yeah.
So the last time I saw you was at our national conference for the Human A&P Society, and you did a very cool presentation on some of the things you do in your classes that are not just lecture lab, professor standing up front bestowing all of her knowledge on people. You do a lot of active, cool things for the students to do as they learn the content. So can you share some of that?
Sure. What I actually always start my classes off with, since I do teach in a flipped format. So, for the listeners that aren't familiar with that format, I actually have them go through a series of homework assignments, going through the details of what we are going to be doing in lab. And then when they come to class, we start with a series of small Kahoot reviews that are going to kind of see what did they learn, what did they not learn, what do we need to strengthen right at the beginning of class. From there, it's open Q&A, and then some creative lab activities that taps into their creativity and their competitive natures. So they seem to enjoy it, and it keeps me active and moving around the room and engaged, and it definitely keeps them moving and engaged. No one gets bored.
Especially when it's a competition. I see that
Oh,
with my students. I mean, once I put a Kahoot up on the screen,
mhm.
they just start getting very excited, and then they start getting very competitive with one another.
Oh yeah. I even have
Yeah.
Dr. Kirsten's prize emporium. I have a little prize box. So when we do any kind of activity with a competition, whether it's individual or solo or a group, it's not anything huge. It might be some anatomical stickers or some office supplies or some snacks that they can enjoy after class, but just something that they can compete for and be able to say, hey, I got a cool brain pencil, or
Oh, that's neat. Do you
yeah.
do you tend to find that the same students winning over and over and over again?
I mix up the groups on purpose.
Oh,
So
good.
they don't know who they're going to be working with from week to week. They sit in their usual seats because they're creatures of habit, but I randomly select the teams so that you don't have that one table with all of the more advanced students winning every week,
Right.
that everyone's got an equal chance.
That's a good idea. Sometimes with my Kahoots, I don't even show that little podium at the end because it tends to be the same couple of students every time who winning
Yeah.
when they're solo. But the idea of grouping them randomly is a good idea. Even maybe when it's not quite as random as they think, and you're putting people together
Hmm.
purposely because you feel they could benefit from being with one another.
Yeah.
I just want to throw this out there. Actually, I'll let you do it. For some of my listeners who don't know what Kahoot is, maybe you could explain that.
Kahoot is a gaming platform, and there is a free version that I was using at first, and it has multiple choice, true, false. There's yes, no. There are even numerical responses that you can use if you wanted to. But you can integrate pictures. It can just be a regular question. I have it set so that the students, they can go in on their device, they see the question and the answer, and they get 20 seconds to select their response. The closest that I can say is it's the game at Buffalo Wild Wings, where it's the trivia game where they have the trivia question and selecting the answer.
Oh, okay.
So it's very similar to that, and we love going there. Um,
I've never been to a Buffalo Wild Wings, so
oh,
I'm not
really?
familiar. There's one in my not in my in a neighboring town of mine, but I don't think I've ever been there.
Yeah,
So
that was
they have cahoots at the restaurant?
well, you get this game board when you go in, and they have
Okay.
all different kinds of trivia games that they play on certain monitors.
Okay.
They have the sports, but it's very similar to what a Kahoot is. It's you get the question,
Got
you
it.
get 20 seconds. Based on how quickly you enter the answer, you get a certain number of points. And so the quicker clickers that are always correct,
Yeah.
they're kind of at the top of the list. But there is such a thing as fat finger, where you meant to hit one thing, but you did the other. So, I'll get people go, no, I fat fingered. And, they're knocked off the podium and someone moves up into their spot. And so they have to know their material to a reasonable degree to compete.
Got it. So
Yeah.
yeah, so I just have I'm not sure if I have fat finger as much as I just have I'm really bad at typing on my phone.
Uh,
And so I know there's a friend of mine got me into this daily, it's a daily mini crossword through from the New York Times.
oh,
There's
okay.
it's really small and but it's timed. You're going for a time. And she was telling me, she's like, I always try to go for under 45 seconds. And I'm like, I make way too many typos to get anything in under 45 seconds. Even if I know the answer, I've mistyped it 4 times. And nobody knows how many typos I make better than you do. So, because you're one of the
We
people
do not make that many typos.
looking at my digital suite content. So, so that's really cool. So, uh, are there any other kinds of like what would you say is like the best active learning thing you've done in your classroom with students?
In A&P2, it's trauma center,
This is
because
what we did at the conference.
yes,
Yes, right. I
yeah,
remember.
they love trauma center. Each I have 6 teams, and I hand them a baggie with 10 patients and their blood types. And I have the blood bank set up in the front. It's just a whole bunch of I love the laminator. It's very soothing. So I spend hours laminating things.
Okay.
And so I've got all these little bags with different types up front. And each person pulls one patient out of the bag. So it's completely random. And the bags don't have the same mixture of patients. So there could be one bag that has 3 O positive, one that only has 1 O positive. So who they have is completely random. Okay, I just grab 10 and throw them in. And then they run up with their patient, they look through the blood bank, and they select something that would be proper for a transfusion. If they're correct, I collect the patient and that bag and I put it aside. They run back to their team, and the next person brings up the next patient. So the competition and the blood bank has limited amounts of type O, very limited on the O neg, very
So they
limited
can't
on.
just like hedge their bets.
Yep. So the winner is whoever can get a proper transfusion for their 10 people first. And I did it one semester where it was 15. So I vary how many patients. Or whoever is the last team standing. Because if you come up with your patient and there is no proper transfusion, your patient has unfortunately passed away and your team has been eliminated.
Okay.
So every once in a while, a team figures out how to rig the game and they take all the O's first.
So everybody else
And
loses.
yep, so everyone else, yeah. The very first
Yep.
semester I did it, a team figured that out very quickly.
Okay.
And some semesters they don't figure it out. and some they do. It's just very interesting how the teams work together and process the information.
Got it. Got it.
Yeah.
That's a good one. I thought that was really impressive when we saw that at the conference, and everyone there had a really good time. And you had a packed house for that
I was
workshop.
surprised.
Yeah, no, it was really good. I was not surprised. It was really good. So this episode, I'm going to be talking about the autonomic nervous system.
Mhm.
It's actually the second half of the autonomic nervous system, and so I was wondering if you had anything that you do that might be relevant to that.
I was thinking about it, and when I was young, they had these pathway books where you would read a little bit of the story and then you'd have to choose a path to take. So if you chose path A, you would jump to page 12 and continue the story from there. If you chose path B, it would take you and say, go to page 21.
Okay. I
So,
think there was like a trademark name for these books, like Choose Your Own Adventure or something like that, right?
yeah, something like
Yeah, I
that.
remember these. I had these when I was little.
Yep. So I was thinking with the sympathetic versus the parasympathetic effects that you could do something very similar where you start them off with a scenario, and based on the situation, they have to select whether that situation would be managed by sympathetic or by parasympathetic. And based on what they pick, if they pick the wrong division, there's a negative consequence, and there's an explanation for why their selection led them to that consequence. If they choose the next pathway, if they choose the other, then it's like, yes, you have successfully, avoided the traffic accident by having heightened reflexes and better vision. You were able to scoot around who pulled out in front of you, and then lead them into the next situation where
I
they
love that
then
idea.
have to, yeah. So I was thinking something like that might be fun, or something of a scavenger hunt, that would still function the same way, where you give them clues, and if they solve it correctly, they get a clue to something else. But I like to choose the pathway because,
Yeah. Well, that's fun because it also is like it gives them a chance to not only take a break from just the listening to the lecture stuff, but also to see if they can apply what they're learning, if they can make predictions, right? So these are the higher level things that we're trying to get our students to do,
mhm.
which is great. I love that idea. Plus, I remember those Choose Your Adventure books when I was a kid, and they were so much fun.
Oh, I love them. I had tons of them. I could just spend hours trying to have like a different story every single time.
Yeah,
So, and it would be something reusable from semester to semester. And I mean, students learn best when they can relate to it personally. So, coming up with scenarios, things that, well, yeah, if this happened to me, or this has happened to me, what happened? How did my body change in response to it? Anytime you can personalize something, it
yeah,
just
for
helps.
sure. Yeah, that's awesome. That is really, really interesting. So I don't want to take up too much of your morning. That was a lot of fun. And I love hearing about the stuff that you're doing. And again, thank you so much for what an enormous contribution you make to Digital Suite, which, for those of you who are listening, that is the digital learning resource for anatomy and physiology that I've been working on for years. And Beth is a major contributor to that. So thank you again. You're doing amazing work.
Oh, well, thank you for letting me work on that project with you. I'm enjoying it in the classroom, and I'm enjoying seeing what you create every time I go in to do stuff.
Well, I appreciate that. That's really nice of you to say. All right. Thank you, Beth. Enjoy the rest of your semester.
All right. Thanks, Steve. You too.
All right. That was so much fun getting to talk to Beth. Not that we don't communicate constantly because of our collaboration on Digital Suite, but it was really good to get her on the podcast finally and have a good conversation about some of the awesome stuff that she does. She's super talented professor and author, and we're so lucky to have her. So I hope you enjoyed that. And now I think we need to get back into the autonomic nervous system and get you closer to your B and A&P. All right, let's talk about the central control of the autonomic nervous system. Even though the autonomic nervous system seems like its own thing, like it's separate from the rest of the nervous system, it's really not. It does have control coming from the central nervous system, specifically the hypothalamus, the cerebral cortex, the spinal cord, and the brainstem. So we'll start with talking about the hypothalamus because it's the main control center of the motor divisions of the ANS. The nuclei in the hypothalamus are like the integrating centers associated with visceral reflexes and also with being hungry and thirsty, regulating our body temperature, our emotions, sexuality. And it does this by sending nerve signals to the cranial nerves of the brainstem and the spinal cord. And from those regions, parasympathetic and sympathetic motor signals can leave the central nervous system toward their effectors. Some visceral reflexes of the urinary, digestive, and reproductive systems have their integrating centers in the spinal cord. For example, the reflexes that let you know that you have to eliminate urine and feces. You got to go to the bathroom. They're called the micturition and defecation reflexes. Micturition is urination and defecation is, when you have to poop. We do have conscious control over when we do these things, but the reflexes let us know it's time. The reflexes that result in an erection and ejaculation also have their integrating centers in the spinal cord. If you think back to the episodes about the brainstem, you might remember that there are multiple centers in the brainstem that are responsible for our vital processes like heart rate, respiratory rate, and blood pressure, for example. Using the cranial nerves and the spinal connection with the brainstem, it also plays a role in controlling digestive functions like swallowing, salivating, and the secretions from your stomach and intestines that help you digest all of the food that you eat. Also, remember from the cranial nerves that the oculomotor nerve, which comes from the midbrain, that's cranial nerve 3, it controls the dilation and constriction of your pupils, which we know are autonomic responses. So the nuclei of the cranial nerves that are involved are mostly found in the reticular formation. And the reticular formation extends from the brainstem all the way up to the hypothalamus, which again, some people consider the diencephalon part of the brainstem. So, however you think of it, whether it's the brainstem is 3 parts or 4 parts, either way, we have extensions from the brainstem into the hypothalamus controlling the autonomic nervous system. And then we have the cerebrum. The cerebrum also contributes to autonomic responses because emotions and thoughts that originate in the cerebrum and the sensations that we perceive with the cerebral cortex can stimulate autonomic activity, like a rise in blood pressure, salivation, or sexual stimulation. Think about when you're angry or when someone threatens you, your blood pressure goes up, right? These are emotions in the cerebrum that are now resulting in autonomic responses. If you smell food, you might salivate. This is a sensation being perceived by your cerebral cortex that is now resulting in a parasympathetic response like salivation, which actually also is a sympathetic response. It's a combination of the two. Remember that the limbic system is part of our cerebrum, and it is the center for our emotional responses. So if you think about our fight or flight responses associated with being threatened, scared, or angry, like I said, those are good examples of how the limbic system of the cerebrum can influence the autonomic nervous system. Now, not every tissue has innervation from both motor divisions of the ANS. Sometimes they only have innervation from one, and sometimes they do have innervation from both. When a tissue or organ has innervation from both divisions, sympathetic and parasympathetic, we call that dual innervation, right? The word dual means consisting of 2 aspects. So it means that it has innervation from both. But not every tissue has innervation from both. Most do, but not every one of them. So let's talk about some examples of how the autonomic nervous system controls tissues and organs without dual innervation. It's important to remember that the autonomic nervous system is not waiting dormant for a fight or flight or rest and digest situation to arise. Instead, they release their neurotransmitters continuously, sustaining their influence on their effectors, whether that influence is excitatory or inhibitory. This is kind of a baseline stimulation or inhibition that's called autonomic tone. Changes above and below the effector's autonomic tone can be made by increasing or decreasing the stimulation or inhibition. A good example is blood vessels. Most blood vessels do not have a parasympathetic innervation. They only have sympathetic. And the sympathetic innervation provides a baseline of stimulation to the smooth muscles of the vessels, and we call that the vessel's vasomotor tone. If the sympathetic stimulation decreases, the smooth muscle relaxes a bit, and that allows the pressure in the vessel to dilate the lumen, increasing its diameter. We call that vasodilation. If the sympathetic stimulation increases, the smooth muscle contracts more, constricting the lumen and decreasing its diameter. That's called vasoconstriction. So imagine that there was no autonomic tone. The blood vessels would exist in maximum vasodilation all the time unless sympathetic innervation was called into action. That would not be an efficient way to control blood pressure and flow. Other tissues and organs with only sympathetic innervation are the adrenal medulla, the erector pili muscles that make your hair stand up, and sweat glands. So let's talk about dual innervation. We typically think of the parasympathetic and sympathetic divisions being opposites and having opposing effects on an organ or tissue. And that's true much of the time. But we also see instances when the two divisions work together to achieve a desired result. Therefore, we see that the dual innervation by the autonomic nervous system can be antagonistic, which is when they result in opposite effects, or cooperative, which is when they work together to achieve the same effect. So let's look at some examples of antagonistic dual innervation. We'll start with heart rate. The heart's internal pacemaker results in about 100 beats per minute. However, parasympathetic innervation from the vagus nerve releases acetylcholine, which is inhibitory to the heart because of its cholinergic receptors. That results in a decrease in heart rate. Those same pacemaker cells of the heart are also innervated by sympathetic neurons that release norepinephrine. Norepinephrine is excitatory to the heart because of the heart's adrenergic receptors. The result is an increase in heart rate. So these are antagonistic effects because they oppose one another. The parasympathetic division decreases heart rate, and the sympathetic division increases heart rate. We also have examples when it's not the same cells that are innervated, but they're in the same organ. Notice that the pupils of your eyes can constrict or get smaller and dilate or get larger. The muscles of the eye's iris have constrictor and dilator cells, which are separate. The constrictor cells are innervated by the parasympathetic neurons, and the dilator cells are innervated by sympathetic neurons. So the two divisions have antagonistic effects. The parasympathetic division constricts the pupils, and the sympathetic division dilates them, but they do it by innervating different cells of the same organ or structure. Sometimes the two motor divisions have cooperative effects, meaning the individual responses they get from a tissue or organ are different, but contribute to one overall result. For example, in the male reproductive system, the parasympathetic division stimulates a penile erection, but the sympathetic division stimulates ejaculation of semen. Another example is saliva. Saliva is a combination of a watery secretion, enzymes, and mucus. The parasympathetic division stimulates the salivary glands to secrete the water and enzymes, while the sympathetic division stimulates them to secrete the mucus. So we get both divisions of the autonomic nervous system stimulating the same gland and coming up with a desired result that is cooperative. All right, the last thing I want to mention in this episode is the neurotransmitters that the autonomic nervous system uses. Because remember, these synapses are chemical synapses, and they utilize neurotransmitters to make sure that their effectors are stimulated properly and to make sure the synapses in the ganglia work. What's interesting is that the neurotransmitter isn't the whole story. What the neurotransmitter does is also dependent upon the receptor that it stimulates. So that's an interesting consideration is a neurotransmitter going to be excitatory or inhibitory? Well, that actually depends on the receptor, not necessarily a neurotransmitter. So let's talk about how that works. First, there's two neurotransmitters that the autonomic nervous system utilizes. Acetylcholine, which is by far the most common, and norepinephrine, also known as noradrenaline. Neurons that secrete acetylcholine into a synaptic cleft are called cholinergic neurons, and the receptors that are stimulated by acetylcholine are called cholinergic receptors. When norepinephrine is the neurotransmitter, the neurons and receptors are called adrenergic, since norepinephrine is also a hormone from the adrenal gland. So that's where that terminology comes from. So let's begin with the autonomic synapses that utilize acetylcholine as their neurotransmitter. And there are three main areas where you're always going to see acetylcholine. First, all synapses between pre- and postganglionic neurosomas. First, all synapses between pre- and postganglionic neurons use acetylcholine. So if the axon terminals of a preganglionic neuron are coming into a ganglia and they're forming a synapse with the neurosomas and dendrites of the postganglionic neuron, the neurotransmitter that is going to facilitate that chemical synapse is always, always, always acetylcholine. That means that the preganglionic neurons are cholinergic and the postganglionic receptors are cholinergic. Second is that all synapses between parasympathetic postganglionic axons and their effectors are also cholinergic. And finally, some of the sympathetic postganglionic axons are cholinergic, which means that sometimes, for example, when the effectors are for sweat glands, sometimes the sympathetic stimulation requires acetylcholine to be its neurotransmitter to the effector. Even though we think of an adrenaline rush as our fight or flight situation, not all of the sympathetic stimulation is going to use norepinephrine or adrenaline. Okay, so there are two kinds of cholinergic receptors, nicotinic and muscarinic, and each are named for a naturally occurring toxin that will actually bind to them. Nicotinic receptors are the only receptors used by ganglionic neurons and dendrites. So in the ganglia, whether it's sympathetic or parasympathetic, the neurotransmitter is acetylcholine and the receptor is nicotinic receptors. Always. That means they're found in every single autonomic ganglion and in the adrenal medulla. Remember, the sympathetic neurons that go to the adrenal medulla are pre-ganglionic, and the ones in the medulla are postganglionic. When nicotinic receptors are stimulated, they always result in depolarization of the membrane toward threshold, which makes nicotinic receptors always excitatory, meaning they produce EPSPs in the postsynaptic membrane. I hope you remember that from previous episodes. Nicotinic receptors are stimulated by the nicotine found in tobacco products. Nicotine receptors are only found in the autonomic nervous system, and we also see them at the neuromuscular junction of skeletal muscles. Nicotinic receptors are not only found in the autonomic nervous system, we also see them at the neuromuscular junction of skeletal muscles. Now, muscarine is a toxin found in certain mushrooms, and it also can stimulate muscarinic receptors, which can be either excitatory or inhibitory. These receptors are found in every autonomic effector that responds to acetylcholine, be it parasympathetic or the few sympathetic examples mentioned earlier. Whether the response is excitatory or inhibitory depends on the type of muscarinic receptor in the postsynaptic membrane. One way to observe this is by recognizing the contradicting effects that acetylcholine has on different organs. For example, acetylcholine from a parasympathetic postganglionic neuron inhibits the cells of the heart's pacemaker, lowering your heart rate. On the other hand, it stimulates the smooth muscles of the digestive tract, propelling digestive contents distally. Adrenergic receptors are only utilized by the synapses between sympathetic postganglionic axons and their effectors. That's the only time you see them. There are two types of adrenergic receptors, alpha and beta, and they each have their own subtypes, and they bind norepinephrine. Norepinephrine is both a neurotransmitter when released into a synapse, but it can also be a hormone when it's released into the blood plasma. Alpha adrenergic receptors are usually excitatory and are subdivided into alpha 1 and alpha 2 receptors. There are more alpha 1 receptors than any other adrenergic receptor in the autonomic nervous system. Beta adrenergic receptors are subdivided into beta 1, beta 2, and beta 3. Beta 1 receptors are mostly excitatory and found in the heart and kidney. Beta 2 adrenergic receptors are mostly inhibitory, and they're found in the arteries of the cardiac muscle and the liver, as well as the smooth muscle of the respiratory airway, the uterus, and the digestive tract. Beta 3 receptors can be either excitatory or inhibitory, and they stimulate the breakdown of lipids from adipose tissue, and they relax the smooth muscle of the urinary bladder. All right, that's going to do it for the autonomic nervous system. The next episode, we're going to get into sensation, which should be the last topic of the nervous system that we cover. It's going to be more than one episode because sensation's a pretty big topic. You'll notice that if you're using an anatomy and physiology textbook, it's a pretty long chapter. I want to thank my guest, Dr. Beth Kersten from State College of Florida and an author on multiple projects with McGraw-Hill Education. Thank you for listening in on that conversation that I got to have with Beth. It was a lot of fun for me. And thank you to the listeners again for joining me. I really hope that these episodes are helping you get that B or better that you need in A&P. Good luck. I'll see you next time. Anatomy and Physiology Bit by Bit is a production of Minus 55 Media. Please take the time to rate the podcast, and don't forget to check out my YouTube channel, Student Help for AP. That's Student Help, the number 4, AP. There's a whole lot of tutor videos on there that I think you're going to find helpful. Special thanks to my family, Bucks County Community College, and McGraw-Hill Education, where you can find Anatomy and Physiology Digital Suite, my low-cost, tutor video-based digital learning solution for anatomy and physiology, already being used at several colleges and universities.